Alright, let's go ahead and look at our do now for today. Our do now is asked to find the volume, so volume, not surface area, of the shape below. So we know that this is a prism, so therefore our volume will be equal to the area of the base times the height. And remember, when we're talking about height, we're really looking about the distance between the two bases. So looking at this shape, first I need to identify the area of the base. So the base here is going to be this triangle, which is a 4 by 4 triangle. So area of our base is equal to 1/2 of the base times height of that triangle. The base and height of that triangle, 1/2 of 4 times 4, which is half of 16. So the area of the base is equal to 8 centimeters squared. And then we need to multiply by the height. So remember, the height is just the distance between the two bases. And so you're looking for corresponding points along those two bases where they're connected. This here is one of those points, and we can see that it's labeled as 6 centimeters. So we're going to plug into our equation. Volume is equal to the area of the base, 8, times the height, 6. And that equals 48 centimeters cubed. So one thing that I'll notice about this is that I did write the equation first. I'm using the equation. Today, if you're not using the equation and you're not kind of plugging in things first, you're really going to struggle. Let's flip on over and write down our aim for today. Alright, today's aim, Kipsters will be able to use volume to solve tank problems. So today we're going to be looking at all kinds of problems, and these are kind of very typical problems that people will ask, that you'll see on various different tests throughout your life, SATs, PSATs, so on and so forth. They love these types of problems. It says a box is in the shape of a rectangular prism and has a length of 12 inches, a width of 6 inches, and a height of 8 inches. What is the capacity of the right rectangular prism? So we're talking about the volume. So basically we're saying we have this shape and we have filled it all the way up to the top with water. So we're looking for the volume of this entire rectangular prism. So this one's pretty easy. That just means we want the volume of the whole thing. The volume is equal to the area of the base times the height. It tells us that it has a length of 12, a width of 6, and a height of 8. So that means our base is going to be what's here on the bottom, which is a 12 by 6. So area of the base is going to be equal to the base times the height of that, base times the height of the base, which is equal to 12 times 6 times the height, which is 8. Again, notice my focus here on writing the equation. If you're struggling to write the equations, then you're going to struggle with today's lesson. So please make sure that you are using your equations to help solve this. This is going to give me 72 times 8. So my total volume of this entire figure would be 72 times 8, which should be 576 inches cubed. Alright, now this next one's a little bit different. It says a glass container is in the form of a right rectangular prism. The container is 10 centimeters long, 8 centimeters wide, and 30 centimeters high. It says the water in the container is 6 centimeters from the top of the container. What is the volume of the water? Alright, so they've done a really nice job for you modeling this particular problem. It tells you that the whole container is 30 centimeters high. So when we're talking about this 30 centimeters goes all the way from the top all the way to the bottom. And we're only asked here for the volume of the water. So we see the water stops here. So the volume of our water is not the volume of the entire container. So we need the volume, the height of our volume actually stops right here at this space. So it's 6 centimeters from the top, which means the height of our volume is not going to be 30. Go ahead and talk with amongst your team. Make sure that you know what is the height of the water. If we're thinking about the rectangular prism that represents just the water, what is the height of the water? Alright, you should identify that the height of the water is 24 centimeters. It's the 30 minus the 6 centimeters from the top. So looking at this distance that we're talking about here is 24 centimeters. So, what is the volume of the tank? Sorry, the volume of the water in the container. So volume is equal to the area of the base times the height. The area of the base, well, our base is down here. So the area of the base is this rectangle, base times height. 8 times 10 is 80. Area of the base is 80. What is the height of just the water? Should have said that the height of just the water is 24. And so for the water, the volume of the water, and I'm going to start to label these a little bit more clearly because there's a couple different volumes we could find here. The volume of the water is 8 times 24, which would be 1,920 cubic centimeters. Now it also asked me for what volume of the tank is still empty. Well, there's two different ways we could do this. We could find the total volume of the tank and subtract away the water. Or, what's another way that I could do it? All right, we could find the tank that was empty by finding the total volume and then subtracting the 1,920. Or, what's another way that we could find the volume of just the empty area? Alright, so if we look at the empty area itself is also a prism, right? The empty area is also a prism. Its base is the same as the prism that we already had, so the volume of the empty space is equal to the area of the base times the height. The area of the base is the same as this because we'd see it has the same shape all the way from the bottom to the top, empty or full. So the area of the base is 80. And then what is the height of just the empty space? Just the empty space is 6 centimeters high. So the volume of our empty space would be 80 times 6, which gives me 480 centimeters cubed. Alright, so let's look at the next one. It's a fish tank is pictured below. The tank is filled halfway. How much water will you need? Alright, so on your problem, this is just 9 inches. So let's fix that here real quick. Alright, so the volume of the tank is filled halfway. Alright, so that means that if I'm looking at this picture, the volume of my tank is only filled halfway. So it is only filled up to this level. So I'm only worried about the bottom half of this tank. Now I know that a lot of us can identify this. We're going to make sure that we write this in equation form. So we're looking at the volume. Go ahead and start by writing the volume equation. Alright, you should have written down the volume equation. Volume is equal to the area of the base times the height. Now, ask yourselves and talk within your group, what is the shape of the area of the base of this prism? So I should hear you say that the area of the base of this prism is a triangle. So to find the area of the base, what is the equation that we need to use? Area of the base is equal to 1/2 of base times height. Alright, what are the base and height of the triangle that makes this up? So the base of the triangle runs all the way down here. Height is up and down. Go ahead and plug in on your own. Pause the video to do so. Find the area of the base. So the area of the base, 1/2 of base times height, 1/2 of 9 times 2.5. Should be 11.25. So the area of the base is equal to 11 times 0.25. Now our volume of our water, and only the water because we're not talking about the entire prism, the area of the base would be 11.25 times the height of just the water. Now the water, it says, is halfway up there. So it would be half of the total height. What is the total height of the prism? Well, half of the height would be half of 5. So it's important that you're able to write this equation this way, because we are going to see a problem later today where you are not going to know the height. You're going to have to put in a variable for that. So half of 5. Go ahead and plug this into your calculator and find the value. After plugging this into the calculator, I get 28.125 inches cubed. Alright, so let's flip on over to the next one. Alright, so looking at this particular problem, this is where we really need our equation. We really need to have our equation here. Alright, so it tells me that 7.2 liters of water are poured into a container in the shape of a right rectangular prism. The inside of the container is 50 centimeters long, 20 centimeters wide, and 25 centimeters tall. How far from the top of the surface is the water? Alright, so we are given the volume of the water. So on our picture here, that means that we're given the volume of just this space down here. And we are not given how tall that space is. What we're given is the volume. So as we write our equation, volume is equal to the area of the base times the height, which of these pieces am I actually given? Am I given the volume? The answer is yes, we're given the volume. So when we're plugging into this equation, we're going to be able to plug in for V, which means we're going to have to do some equation solving. So it tells me it's 7.2 liters. It gives me the hint down here that 1 liter is 1,000 centimeters. So really, to convert my liters to centimeters, it's 7.2 times 1,000. So again, I need this to be in cubic centimeters, so it's going to match my units of my volume. So I'm going to multiply, and that's going to give me 7,200. And again, this is the volume, so I have to plug this in for volume. This is the volume of the water. The volume of the water is 7,200. The area of the base. All right, we can find the area of the base. Go ahead and find the area of the base. So the base of our prism, area of the base, is equal to 20 times 50. Area of the base is equal to 1,000. So where am I going to plug that into my equation? Well, that goes in directly for the area of the base. And the height. Do we know the height of the water? We know the height of the entire prism. We do not know the height of just the water. So this is where we're using the variable h, and we're going to have to solve for that. So how do I go about solving this particular equation? So we've got one step here. Go ahead and solve this equation amongst your group. You should identify that in order to solve this equation, the one inverse operation we need to do is to divide by 1,000. I divide both sides by 1,000 to solve the equation. This cancels out, leaving me with h is equal to 7.2 centimeters. So our height is 7.2 centimeters. This is the height of the water. Now, what we have to be careful is this is the height of the water. So we were using the volume of the water, which means we only know the height of the water. The question actually asks us not what is the height of the water, but how far it is from the top of the container. So, how am I going to figure out how far it is from the top of the container? Please discuss amongst your group. So you should have discussed amongst your group that if it's 25 centimeters tall and 7.2 of it is taken up by water, that's going to leave me with the subtraction that the height of the empty is equal to 25 minus the 7.2 that's taken up with water. That's going to tell me the height of the empty space is going to be equal to 17.8 centimeters. So again, we're able to find that because we know the total thing is 25, so we're looking for the difference between the total and what's the water's taking up. Alright, we got one last problem over here. It says a tank is in the shape of a right rectangular prism and has 27 liters of fuel in it. The inside dimensions of the base are 90 by 50. So when we're thinking about this, our base is 90 by 50. And as we draw this, we know that it is 3/4 of the way full. So if I'm looking at my fuel level, my fuel level only goes so far up this particular rectangular prism. So I don't actually know how high this is. But what I do know is that it goes 3/4 of the way up. So it is only 3/4 of the way full. So we need to start modeling this with an equation. Alright, so our base is 50 by 90. Our height is unknown. Our height is unknown. So let's start modeling this. We use our equation. We know the volume of the fuel, is equal to the area of the base times the height of the fuel. Alright? So the volume of the fuel is 27 liters. We need that to be in cubic centimeters. Again, they told us this earlier. That means that this is 27,000 cubic centimeters. Because 27 liters times 1,000 gives me 27,000. Plug in the area of the base. Well, the area of the base, come down here and find it. So you and your team should recognize the area of the base is 50 times 90, which is going to be 4,500. And now the height of the fuel is only 3/4 of the height of the entire tank. So this is where we have some decisions to make. We could find just the height of the fuel, but this actually wants me to know what the height of the entire tank is. So if the height of the fuel is only 3/4 of the height of the entire tank, then I want to put into my equation here that I want 3/4 of the height of the entire tank. So notice the height of the fuel is equal to 3/4 of the height of the entire tank. So when I've plugged into my equation, I've replaced it with this expression here. So now I have this equation. 270,000 is equal to 4,500 times 3/4 times h of t. So I'm going to simplify this by multiplying the 4,500 times 3/4. If you want to put that in as 0.75, you can definitely do that. By simplifying this, 4,500 times 3/4, I get 3,375 times h of t. Remember, h of t is representative of the height of the entire tank. And so go ahead and solve this equation. This is a one-step equation I know all of you can solve. So go ahead and do that on your own. So looking at this, we're going to go ahead and divide by 3,375 on both sides. And that's going to tell me that the height of the triangle, or the height of the tank, is approximately, and I'm going to have to round this answer, is approximately 7.55 centimeters. Right? So this is our answer. The height of the tank is about 7.55 centimeters. So again, as we think through this, what's going to help you with your work and these word problems is first identifying the equation that you want to use for the volume of a prism, and that's where we start every time. This is kind of that discussion that we've been talking about before. Write your equation, plug in the information you know. We know the volume of the tank was 27 liters, which meant it was 27,000 cubic centimeters, so that's what went in for my volume. I was able to find the area of my base, and so I plugged that in for the area of the base, and the height I knew was only going to be 3/4 of the total height. So that's why I put in this part as 3/4 of the total height and not just the height, because we wanted the height of the entire tank, not just the height of the fuel. Alright, so once we had that, then we could go through, everything was plugged in the equation, then it was just a matter of solving an equation, which you guys are phenomenal at. Alright, so again, please make sure that you're thinking through, start my equation, plug into my equation, then solve for what my unknown is. Alright, let's flip on over to your alone time and get your alone time done. Actually, before we move on to your alone time, I do want to acknowledge I had a calculator error. I put this into the calculator wrong. This actually should be exactly 8 centimeters. Alright, this should have come out to exactly 8 centimeters. So when we did that division, the height of the tank should have been equal to 8 centimeters. Alright, so go ahead and now move on to your alone time. One thing I just want to flag for you on this first problem is that this asks us how deep the water is on the first problem and how deep the tank is on the second problem. Go back to the previous example and think about which equation and how would the equation change if you were looking for just the height of the water or just the height of the tank. That should be a thought process that helps you fill out your equation as you go ahead and set up this equation to find the volume of the water, or use the volume of the water to find the height of these two particular pieces.